Today, guys, I think I cooked my test for Com 1140. We're gonna try to finish up some 2024 questions, maybe finish at like 1-ish. Try to save my energy for tomorrow's marathon of about 25 to 30 questions. But yeah, we just take it one paper at a time. Sorry, what I meant is a question at a time. Yeah, honestly, I hope my paper does well. I think I worked hard to fucking prepare for that paper. It was a relatively not hard, but like, how do you say it? Long paper? Yeah, I think so. It's pretty long and pretty tedious paper, I'd say. And so I was also able to hit the gym today, which is pretty nice. This was me being able to breathe a little bit and just kind of work out and feel good about myself. Okay, firstly, we want to look at this. So he's saying that for part A, right, what this guy's dress looks like is basically there's a hole in the dress. The dress extends out, and there's a hole in this dress. So this is basically the dress when it's flattened, right? Like that's the waist, and that's the basically. Right, and so this is radius R. And this is radius from the center, right? Same center. This is L. This is radius W on 2. So the diameter is W, and this is R, okay? Oh, what the hell is that like? Oh, it's 2 questions. Basically, he likes the edgy design and decides on a skirt that comes out. Sorry. Right. It's got this type of design. This is like a 2D flattened. Right. Then we're trying to find the area, which would be composed with the basically think of this now as a 3D box. And now you've got things that are 3D, right? So you basically got this big box, and you've got this waist diameter here, and you've got this waist diameter there. This size here, that's R. I should just draw it like that. Basically, right? So this is whole waist part, right? Right. He likes the skirt that comes out horizontal from the waist, then drops straight down over the hips, as in this figure, right? So we should have imagined that that's exactly what he was going to draw. Right. Then the area would, well, the area would need to be area, right? The area would have to be this. Right? And this, sorry, no area here. Skirt. So no area below. But you've got this type of area. Right? Basically. So this area of circle of donut. What the fuck? This equals to pi r squared. Sorry. No ChatGPT. Just try to understand each question first. I can work through them slowly. It's been a tiring day. Right? It's basically the area of the donut minus, sorry, right? So this is the diameter W2. This is the radius R. So we're taking big circle area minus, right? Area big circle minus area small circle. Right? And they wanted to see that we could factor pi out, and we'd have r squared minus w on 2 squared. you ask me why there is a pi and 4 on the outside. Well, they have basically made it pi r squared minus w squared over 4, right? And so if they want to bring this out, right, if they want to factor this out, they need to multiply everything by we're gonna do pi on 4. Why is it 2 pi? It's this one, right? Wait, why is it the first one? Huh? What the? Okay, cool. Yeah, you have to multiply everything by fucking. So multiply everything by 4 here. And then on 4. Which is equals to pi on 4. So that's area of a donut. I'm just being fucking unproductive at this point. We've derived it. Nice. Grace prefers a curved skirt profile as the figure and chooses that function, which is part B, which is the black one, right? The more general one. Then she has that formula, that function that goes from 0 to L. So we're thinking of a x on y type of equation. Yep. That's fine. Using the formula above, she's going to kind of flip this sketch over, and she wants to probably have a formula over the revolution of the x-axis, which is that, okay? Using the formula for A above, Grace calculates for their skirt that A curved, the area of the curved, 2 pi times T shine it is a trigonometric and B and Y are just constants with that. So some function of f, is that what you're saying? Right. I mean, if we set it equals to something and then factor these bad boys out, then we're able to use Maple once again to just clear most of this information. Okay. So we start with a x function, right? Usually we do a function of x. Let's just call x this, right? Minus cosh 0.97y over 0.97 plus some t. Right. Then we want L. L is that side. That's the length of L. She's going to integrate from 0 to L. So we're going to do the same. We're going to do the integral of 2 pi times x times square root 1 plus diff x in terms of y squared for the integral from y is between 0 to L. Wait, I think I fucked up. That's better. Right. So we get some function. We get a function 2 pi times 1 plus shine squared sorry, I'm trying to see what this looks like. some function over gamma minus L. Where's that minus L? I thought we integrated from 0 to L. Yeah, integrate. Or do you want me to integrate? Okay, maybe we could integrate y normally. So it looks like we have to integrate by ourselves. Integral 2 pi times the integral of 1 minus, we're just going to bring that out, right? Yeah. 2 pi integral, or now let's keep it inside. We know it's a constant. Right. Times cosh 0.97y plus t times square root 1 plus derivative of 0. Right, so we're trying to find the derivative of this with respect to y, and t's a what? T's a constant, right? So dy of well, it's basically shine times this, right? Times the inside, which is that. So that should cancel to get like just like shine, or we get like right. Just to make sure, what we'll do is we'll diff x in terms of y. Right, so we get minus shine. That's good. If we have minus shine in here, right? Minus shine squared dy, right? We have to notice what they're doing. Well, this is 1 plus shine squared right, which is since cosh u shine squared u is 1, cosh squared u is equal to sine squared u plus 1, right? So what I essentially have is a integral that goes like this. Cos squared okay, and then we get, do we get a cos cubed? No, we just get a cos here. Then right, so we have basically and then now we can integrate by parts, right? You integrate cos squared, what do you get? And you integrate sine, you got a cos. But we have our table of integrals out. If you integrate cos squared, what happens? That's the 1 over cos squared. What does happen when you integrate cos squared? Int cos squared. Do we have methods for solving cos 1 plus sine squared? How to integrate cos and sine squared. Where's my fucking course notes? We're using shit like this, right? Oh, U substitution. What do you want to use up here? You want to use the... Do you have an extra cosh anywhere? It's addition. So you break that into 1 plus... How's everything I've done to this point work? Right. So the inside is cosh. You multiply that by the whole thing in t. This I know immediately connects to this. Right? Then we'll just integrate this. Use up for cosh, huh? Cosh minus shine gives you that. Cosh times cosh is cosh minus root shine, maybe. Single trig or hyperbolic function. Would you do like, I don't know. I don't know where to use shine. ChatGPT it is. Alright, now I'm trying to integrate. I have 2 pi times the integral from 0 to L of the quantity of minus 1 over 0.97 times cosh. The cosh function of 0.97y plus t, close the quantity, times the square root of 1 plus the derivative of the function we just talked about, which would be minus shine, right? So minus hyperbolic sign in the inside of the square root. So we'd notice 1 plus hyperbolic sign squared of u, or just 0.97y in this case, is equals to cosh 0.97, cosh squared 0.97y. And so I was able to take out the square root. That's fine. Then we've got some functions of cosh in which I try to integrate firstly by expanding the cosh and then using integration by parts. But now I'm stuck with the part where it's cosh squared, I don't know. I haven't used it long enough to notice what I should notice. I'm getting really sleepy. Colin. I'm dreading. I need sleep right now. There's nothing I want more right now than to fucking fall asleep in my bed. Use that identity. Cosh squared is 1 plus cosh 2u over u. Never used that before. Cosh. Is it in Math1231 that I should have known this function for cosh? Where could I remember cosh squared? What a pain, eh? Teach me how to derive this cosh function. Ah, found it. Double angle. Okay, so there does exist double angle formulas for cosh. So that's a tool that I missed. New toolkit. Double angle formula for cosh squared u is the same. Find using cosh squared u plus sine squared u equals cosh 2u. Then you get cosh squared u is equals cosh 2u minus sine squared u. Which is equal to cosh 2u minus 1 plus cosh squared u. Is that right? What's the identity we want to be looking at? Okay, that's not the right identity. It's probably what, 2 times cosh? double angle formula. I don't use these guys enough to remember. If you don't use it, you lose it. But I would not give a shit because it's like I could learn it again. Cosh squared x is equal to cosh 2x minus sine squared x. How do we derive that? No. Not about deriving. How do we turn that into something that we could use? Sine x is cosh minus 1 minus sine x is equals to 1 plus cosh. Oh, yeah. Wait, no, it's minus cosh squared u, right? So now you have 2 cosh squared u. Therefore, you have cosh squared u is equals to cosh 2u minus 1 on 2. Okay. So now that I know the double angle formula, I'm going to use it. I get 2 pi cosh 2 times right. Right. Oh, this is a pain, bro. Cosh squared is equal to that, which is equal to Okay. So now I have that. This becomes L shine. But this is just the... Yeah, it is just this part. So this part goes to shine, this part goes to... Right, this is essentially this. Right? I want to factor this out. Is it 2? And then we can finally integrate, which is 1 over 1.94 times, right? We're using cosh. And we're turning all that into shine. So 3.88 shine, 1.94 L plus L on 2. But there's also this. Where did the -1 over 0.97 go. You didn't factor it out, didn't you? I know you did split the cosine, the cosh squared term into 1 plus cosh 2u over 2, right? And then you're also able to split that up, but wouldn't you need to multiply in that minus 0.97 part that you took out? Or is it because they subtracted it? Okay, so I have to multiply back in. This is why we integrate by parts, because it's better this way. Oh yeah, okay. Which they're saying is equals to right. How much was this again? 2 times 1. Or is it like 4 times? Yeah. I think it's already like 4 times that. Like 4 times 0.97. Then you. So this is basically minus shine. Right? Over so 0.97 squared times 4. Minus L on 1.2 times 0.97. Basically. Right? So this matches. This matches. And now this should be this. So f of u should be minus shine u. We should have 1.94 beta, and gamma is equal to this squared times 4. Wow. it shine? 1.94. What's 1.94? That's 4 times 1.94, no? Why does it shine you? 2 pi something. I need to do this again. We need good paper. We're going to start with this. Sorry, we're going to start with this one. Right. Is that our formula initially? Yes. Right. No way it's going to be like a negative here. Bro. Okay, so I got it right. That's right. Somehow they want sine u this negative 0.97 squared times 4. Okay, I can live with that. As shown in the figure at the bottom, width of the script profile of could we done that? Could we have done that a little bit faster? Maybe we could have done 1 over u cos u y derivative, or a cos a, or we could have possibly tried integrating using this. So maybe I try integrate cos 2 1.9794, right? So 2a plus 1 over 2, is that right? Plus t cos ay ty. If we integrate like this, it could possibly work. It'll be a lot cleaner for us, as long as we go 2 times pi times the integral of 1 over a times cos 2a times y plus 1 all over 2. My bad. All on 2 whole squared, right? Whole squared plus some t times cos of a times y. And then we're integrating from y from 0 to L, which gives you that. Could we expand that? Expand. That gets us that. We get 2 pi shine TL. And we could factor out 2 pi. Just pi shine cosh, which doesn't look good in our case. Maybe if we integrate like that, what do we get? Shine AL cosh AL, which we fortunately did not have. Is that because of an error that we wrote? Possibly. 1 over A times this whole thing on 2 minus 1 over A times the quantity of that shit over 2 plus T cosh AY. And we get some T over A shine AL. And then we have a shine over 2A squared, which is, wait, shine over 2A squared. Two AY plus 1 half. We're getting close. L over 2 times that. We can find gamma basically right away. But the only problem is there's an extra caution there, which leads me to believe something's going on with our function. Because our function wouldn't behave that way if we, you know. Simplify in could I do sine u cos u? Could I have in how can I integrate in Maple? Is this the right Maple input when I let A be 0.97 instead? I do see the T shine of AL over L minus L over 2 times 0.97 minus the thing that's bugging me is why there's a shine function times a cosine function, times a cosh function. Because everything else seems to be in the correct form. What's going on with our integral? So I could use that. Shine you, kosh you. Could I use shine you, kosh you? Just shine you. So notice that that is yeah, I guess I could. Okay, that is equals to 2 pi times T shine A L over A minus L over 2A minus shine AL kosh AL. And this is by Math1231. Fuck, man. Does this work? Actual pain in the ass that I have to solve this. I have to solve this. It's okay. Solving this is not too hard, not too bad. Right? You know the method enough where like you could like I have the method in my head. Why is there 2 pi there? I guess you're right. Yeah. Yeah. Oh, fuck. I was only able to factor this out by myself. So you cannot do that, Jaden. This, you have to do it like this. If you know what I'm saying. It's like you have to do 2 pi on a integral L of whatever plus integral 2 pi of t cos ay cy cos 2 ay. Yeah, that works. Which we will end up with a half times half a times sine 2ay plus y on 2 L0 plus 2 pi on a times sine times t. Let's just keep 2 pi out the way. T on a sine ay L0. Yeah. So we have pi on 2 pi times minus so I have to put this minus on the fucking bottom. Minus 2 times, or minus a at least, times a half times 1 over 2a times sine 2a plus minus y on 2a plus 2 pi. Holy shit! You know how long that just took me? An hour to do that question. The bottom width of the script profile of Grace is XO R plus W12 plus E. Use this and write the value of XL from 1. Okay. Let's continue to this. Wow, I feel like awake after doing that question. That was a hefty load of a question. Could I do that question again? Probably not. Jesus. What is that? Oh, elected. Next part of this question, of a ready hard question, they're gonna give us what? Yeah. As shown in the figure, the bottom width of the profile x0, function of x at 0 is the bottom of the width of the skirt profile of Grace. This equals to the radius, which is equals to W on 2 plus some E. So it's that point right there. X equals 0. Sorry, function of x of y, where y is equals to 0. Right? The bottom of the width of the skirt profile. Enter the answer for EL. So what's the distance? Do I know? Well, I do know that the end of that curve does evaluate to some degree of something. Bitch, I wish I knew. Since xy is that, x0 is that. So I have xy and I have xl. E is that. Minus E is equals. So we're trying to create a function for L. Right. All the more important to use some of this. What's an important one? X. That's it. That's all I need here. X is that. Is some function of y. Subs y is 0 into x. We get our first function of cosh 0. That's 1 over cosine 0 is 1 over 1. Fuck me, bro. These calculators can't use hyperbolic functions correctly because they just can't mathematically. Yeah, I honestly like this question. I hope it doesn't come out because just because x0 is equals to what minus 1 over this cosh 0 plus t. Cosh 0 equals e to the 0 plus e to the 0 on 2 is 1. So this is equals to t minus 1 over this. Right. What? Which is equals to what? I have that. And okay. So I'm trying to find this is find x0 and find xl. Wow, I feel like shit because I can't smell. I cannot smell, bro. I feel so bad that I can't fucking. Where the fuck did my Vicks go? How do you know that x0 is equal to? Oh, because E is the distance between. Oh my god. Yeah, yeah. No way in hell anyone knows this. Except me, because now I get the question. But. Right, so we're finding. Trying to find XE, right? So I have to think about like this. This is X from. This is. Okay. So XL is the top. What's XL? Cosh of what? À, đầu vãi đạn. Đầu vãi đạn luôn ạ. Đầu lừng quá luôn ạ. 0.97L plus T. Then L. E is this part. The distance of the value at some function x evaluate at 0, right? Yeah, I can imagine that. Minus the height. So height minus height at L. Okay, is that the answer? That is the answer. Final question. As long as I have the method, bro. So what do they do? Use this function, eh? WRS, WES. E is that. W is that. Find E pi times that. What's S? S is that. Okay. So just a bunch of numbers that I'm supposed to compute, right? So I let W equals 0.334. I let E equals 0.34 divided by 2 plus, sorry, E is equals to 0.34 on 2 minus R. R is what? That much. Right? Why is it positive? Positive or negative? R minus. Okay, my fault. My fault. S is equals to square root E squared plus W squared. So remember that W is the same as E. Pi times W plus E times S. Nice. Why is his arm so fucking massive? Why is he so đẹp trai, bro? Làm sao ta có thể bước con như nó? Like a good you control. What the fuck? How to get tan. Okay, this is a good question to end the night. Because I did not like that final question. Ethan needs your help to solve an initial value problem taken from a book. This is a what? Ugly ass fucking, well, dy over dt y squared over 64 y squared plus 64 t, which is right. So it is a separable first order using, you find an expression in the form using the relevant method of integration to the, you want me to integrate? Whatever. No, I'm going to integrate using maple because maple's goated. What we're going to do desolve, open bracket, diff y of t is equals to y squared on 64 times y squared plus 64 with y0 being 1, y of t. Sorry. Right, we have that good form. Y looks like t is 0. Write down the function f of y minus g of t. Fuck is f of... Ugh. Oh my god. So they do want me to integrate like this. What substitution could I use? I could use a 64 times y squared plus 1 on y squared. Right? Which now gets me 64 comes out. Right? Let y squared equals u equals y squared. du is 2y. Nope. I'll let Maple integrate. Is that it? (64y) minus 64 over y is equals to t squared on 2 plus c. Then y0 then ow, ow. Ow, no, what, no, 64. Right. You want a unique solution? Huh? So that looks like a crappy version of the quadratic formula, which would be what? Why did they let this equals b? Okay, whatever. Probably something about positive discriminant, or discriminant equals exactly 0. Function y behaves as t equals to positive infinity. Dude, if you asked anyone this, okay, no, just I'm in so much pain right now. My body hurts. My body actually hurts so bad. The initial condition y0 is equal to 1. Oh, okay. Since we have the initial condition being y is 0 to 1, setting y of 0 equals 1 for the plus case, 1 plus 16 a squared times b I can cross that off my list now. It looks like I won't do any 2026 questions yet. And 2020 these questions, I'll leave them for some other time. I have to finish 2025 questions first. factor. Okay. Why the fuck did he substitute that straight back in? Well, I think this question could come out. We know how to solve this. We know how to solve this initial value problem. And we know that we need to factor the inside out. And it's very, very like heavy. It's fundamentally calculus is very beautiful in its own sense where you made out this problem. You're factorizing this out so that this can come out as t squared so that you can also split this up so that you can factor this out, right? And then now you're gonna see, oh my god, I've pulled back down to kind of fundamental analysis where I see that as t goes to infinity of the limit here, right? This is gonna turn into root 1. So the inside is gonna basically be equals to 2. So it's basically 2t, so it's basically t squared over 2b. Then that means, so we'll see, as t goes to infinity, yt is basically equals to that. So we need yt divided by 2, which will get me that, which will be a finite number. See, that's a really nice question too. This question, not so much. Yeah, I think that's me logging off for today. Yeah, good night, guys. Bye bye.